Find the center, vertices, foci, and the asymptotes of the hyperbola. Well, the center is very easily identifiable because you know the standard form. You have the standard form memorized. I mean, it's x minus h quantity squared over, in this case, parabola. We could just keep the a squared there, minus y minus 6 quantity squared over b squared is equal to 1. Oops, I said y minus 6. I meant y minus the letter k. And so you can easily identify the center. The center is parentheses -9 comma 6. It'd be nice to be able to find the vertices. With this standard form, the two hyperbolic branches open left and right. So the vertices are here, and the foci are located right there. So they're all going to have the same height. And of course, the center is right here, the little blue dot or blue star. The center, we already know, is actually -9, 6. So there is sort of a rough sketch there. If we zoom in, we can actually get a rectangular box. What do you mean? Well, there's actually a rectangular box right about here with the blue star. Blue star is -9, 6. And we need a to be 3. So over here, we can draw a little triangle here. We could actually draw one of the vertices. You have to go 3 units to the right. So we have -9, 6. And if you go 3 units to the right, then we're at -6, 6. So one of the vertices is -6, 6. And if we go 3 units to the left, we get the other vertice as well. We get -12 comma 6. So we got the vertices that way just by drawing a really, really rough sketch of things. Vertices is -12, 6. And -6, 6. I should probably write my grammar correctly, because there's 2. We would say R. There we go. Now, it'd be nice to find the foci and the asymptotes. Well, with every hyperbola, there's this little rectangular box where it's 2a units wide and 2b units tall. So why don't we locate another ordered pair here? Let's locate this ordered pair. Well, we need to go, what? 4 units. I'm sorry, we need to go 7 units up. So we have, from here to here, it's 7 units up. And from here to here, this is 3 units this way. So one of the asymptotes is this black dotted line. And so it has a slope already. Let's call this asymptote number 1. It has a slope already. That slope is 7/3. So y minus y1 is equal to m times x minus x1. And we're going to go ahead and use the center to be x1, y1. x1, y1 is going to be the center, which is equal to -9 comma 6. So we have y minus a 6 equals 7/3. We have what? X plus 9. So there's an equation of one of the asymptotes. And if you wanted to, you could put this in y equals mx plus b form. It's not a problem. So we're going to add 21 and then add 6, so 27. So there's one of the asymptotes. Here's asymptote. The other asymptote would have what? The other asymptote would cross over, let's say this line right here, this blue dotted line. That slope is what? That slope is m sub 2, I guess. I can call this m sub 1. M sub 1 was positive 7/3. Let's find this m sub 2 slope. Well, it's negative now because it's pointing down. So you actually had to go down 7, right 3. And you could use the same, the same point slope formula to find the equation of the line. So y minus y1 is equal to now m2x minus x1. And x1, y1 here is just the center of the hyperbola. So y minus 6 is equal to negative 7/3 x plus 9. And once again, you could put this in y equals mx plus b form. This time we have minus 21 add 6. So minus 21 add 6 is negative 15. And there is your second asymptote. So there are two asymptotes there. We so far have the center. We have the vertices. The only thing left to find are the foci. And finding the foci, there's a relationship. So finding foci, there's a relationship between a and b. C squared is equal to a squared plus b squared. And we have what? C squared is now, what's a squared plus b squared? That's going to be 9 plus 49, which is 58. And if you take the square root of both sides, we get the absolute value of c is now equal to the square root of 58. 58 is not divisible by 4. There's no perfect square in there. So we're going to just say plus or minus, just say the square root of 58. Jumping ahead of myself here. Just say the square root of 58. Now, how do you solve an absolute value equation? C is equal to plus or minus the square root of 58. We also know that c is greater than 0. It's always the distance between a focus point between a focus point and the center. So c is greater than 0. That means c is really square root of 58. Make sure you are showing all these steps here, though. I'm going to circle that as if it was a final answer. You're supposed to replicate those steps. Now, that isn't the foci. So why don't I leave myself a little bit of room here? The foci is what? Well, the parabola is going to open, remember, left and right. So the foci has the same height level as the vertex. In other words, it's still 6 units up from the x-axis. So if that's the case, then we just keep the y value to be the same and we move the x values. So let's look at the foci now. If we keep the x value, which is negative 9, and then add or subtract square root of 58, and then write comma 6, we should have the foci. So the two focus points is negative 9 plus root 58, comma 6, and then comma here, negative 9 minus root 58, comma 6. And there you go. You got the focus as well, or the foci, more than one. I'm going to circle this one. This one's the final answer, but make sure you're able to show all your work. We have everything. We have the center, we have the vertices, we have the two focus points, and we have the two asymptotes as well. Let's refresh our memory on how to graph a parabola. So this is y equals negative ax squared minus bx, or plus bx, plus c, right? Remember, subtraction could be interpreted as add the opposite. There are many ways to do this, but we're going to use a form that gives you a vertex. And I'm going to use this graphing form. Y is equal to a times x minus h, quantity squared, plus k. So this is the original form that you probably learned in a beginning algebra course. And we're going to just refresh our memory on this. The key here is know how to complete the square. That's very, very important. So completing the square will allow you to write y equals negative 2/3. And we're going to complete the square on the x squared plus something here. What do we have to do there to get 8? So negative 2/3 times blank gets you what? Negative 8. So what would blank have to be? The blank would have to be a negative 24 over negative 2, which is known as 12. So the blank is 12. If you put 12 in here, we're in good shape. We actually get negative 8. Now leave a space there, and I'm going to write subtract 26 out here. Remember, when you're completing the square, there should be an x here. Take this middle term, take 12 divided by 2, you get 6. Square 6. If you square 6, you get 36. But you didn't add 36 to the right-hand side of the equation. In fact, we're going to try to add 0. So we're going to actually add a 36 times a negative 2/3. We need, I need a subtraction sign, excuse me. Let's go back, change that to a subtraction sign. There. Now we have an opposite amount. So we actually added 0 to the right-hand side of the equation. Let's go ahead and simplify this. Y is now equal to negative 2/3. Why did we complete the square? So that we get a perfect square trinomial. We get that. What do we have now? We have plus 24, so subtract 2. We only had left with a subtract 2 left. And now we have it. We have this parabola in a graphing form where you could recognize the vertex. The vertex is HK. And in this case, it's parentheses negative 6, comma, negative 2. The parabola is opening down. How do we know that? Because your coefficient on the 2/3 is negative. So we know it's opening down. So there will be a maximum y value in this parabola. You know, that's really why we study parabolas, is to notice if we have maximum or minimum values. We could draw a quick sketch of this. It might be wise to find a y-intercept. So y-intercept occurs when x is 0. So if you try to find a y-intercept, occurs when x is 0. So y is equal to negative 2/3. We get 6 squared, which is 36, and then subtract 2. So 36 divided by 3 is 12. Negative 24 minus 2 is negative 26. So that might be off the table a little bit, but we could draw a parabola that's not to scale. Let's try this. Let's draw the vertex. The vertex is negative 6, negative 2. So maybe about here. And what I'm going to do is actually just label things. Negative 6, comma, negative 2. I'm going to say this graph is not to scale, just so that I could draw a pretty generic sketch of this parabola. We know there's a y-intercept. The y-intercept is 0, negative 26. So let's just say it's way down here. And that is about 6 units away. So there's 6 units away from the vertical direction of the vertex. So why don't we draw an axis of symmetry right there. Remember, this axis of symmetry happens to be a vertical line, and we describe vertical lines with x equals. x equals -6 is the vertical line, or the vertical axis of symmetry. We're ready to connect the dots. I should label this other ordered pair though. This other ordered pair is what? -12, -26. And we could connect the dots here and you get a nice graph. There you go. So there, you graphed a parabola in this form that you did before. It just may have been a while, so refresh your memory on that. I recommend that you have to have at least 3 ordered pairs, and one of them has to be the vertex. All right, we're going to look at another conic. So you've looked at circles, ellipses, hyperbolas, and now it's time to look at a parabola. And what do we have here? We have y squared equals a times x. And we're going to do a couple of different examples just so that you know that this is a graph. And so it doesn't always have to be a function. This time we're just going to draw a sketch or a set of ordered pairs. And those ordered pairs doesn't always have to be a function when we're talking about conics, right? An ellipse is not a function. A circle is not a function. A hyperbola is not a function. And the parabola is also not always a function. It just depends on which way it's oriented. Let's write the general form of a parabola using the definition. The definition would say y minus k quantity squared is equal to some a times x minus h. And if a is positive, it opens to the right. If a is negative, it opens to the left. In this case, what do we have here? We have y minus 0 quantity squared is equal to -2 times x minus 0. So the vertex, remember the vertex is h comma k. So here the vertex is 0, 0, not a total surprise. We could go ahead and plot that. And then we know it's going to open to the left. We're going to open to the left here. So it would be nice to pick at least 3 to 5 ordered pairs. So why don't you pick x to be 1? Or you should, how about we do it the other way? Why don't we pick y to be 1? If you choose y to be 1, that implies that x is -1/2. And if you choose y to be -1, we get the same value, right? So we get, so we get we have an ordered pair here and here. If you don't like that, we could write what? -1/2 and 1, and then -1/2 and -1. This tells you that this is not a function because this has 2 y's for a single x, and this breaks the rule of a function. So here we're just drawing a graph. We're drawing a set of ordered pairs in the Cartesian plane. You might want to pick y to be 2. That might be a better way to get some decent ordered pairs. If y is equal to 2, we get x to be -2. And if y is equal to -2, we get -2 squared equals to -2 times x. You still get x to be -2. So once again, you get ordered pairs, -2, comma what? Comma 2, and then -2, comma -2. Get a parabola here. There we go. And then play connect the dots. Opens to the left. Make sure you draw this on your own paper. Use your graph paper if you have it ready. If not, just be neat and label everything. You can certainly put all of the ordered pairs in a T-chart as well. negative 1/2, 1, negative 1/2, negative 1, negative 2, 2, negative 2, negative 2. That would help you. How about this one? This time I'll make the t-chart first. How about that? Let's write it in one of its standard forms. This standard form is a little different. This is x minus h quantity squared is equal to a times y minus k quantity squared. I shouldn't call this standard form, but this is more related to the form called the definition of a parabola. It's equal to negative 2 y minus 0. So the vertex is once again 0, 0, but this is not going to open left or right. Do any of you know which way this is going to open? You can always pick ordered pairs here. Why don't we pick x to be negative 3? So if you pick x to be negative 3, we get negative 3 squared is equal to negative 2y. So y is equal to what? 9 over negative 2, which is negative 4 1/2. And if you pick x to be 3, we still get what? 9 over negative 2. So when x is 3, we get 4 1/2, negative 4 1/2, right about here. And x is negative 3, we get negative 4 1/2. So we get it here, play connect the dots, bam. We have a parabola that has a maximum. The maximum y value is 0. Yeah. So this one happens to be a function. This passes the vertical line test and the rule that says for every x, there's exactly one y. Over here, this one is not a function. This is not a function. So make note of that. Oh, we graphed both parabolas. Oh, I need a t-chart here, 0, 0. Should put the most important ordered pair. You gotta have the most important ordered pair in your t-chart if you're going to go with a t-chart organization. Let's circle our graphs and circle our labels. That's what we need. Let's circle our labels. Let's circle our graph, our labels. Yeah. And it's good to know that this is not a function, and this one is a function. Graphing a parabola of the form x equals a times quantity y minus k squared plus h, or y equals a times the quantity x minus h squared plus k. I typically like to switch this so that it looks a little bit more like a conic section, and it looks more closely related to the definition of a parabola. Okay, so I usually switch it like this. And for me, this is a little bit easier. That way I could always remember that the k is actually a y value. And that the h is actually an x value. So typically I memorize these equations like that. So here I would write x plus 7 is equal to negative 3, y minus 3 quantity squared. There's some advantages for writing it this way. You could actually find the directrix and the focus if you write it this way. Whereas if you leave it the other way, it might be a little bit harder. Let's identify the vertex, which is negative 7, 3. And then from here, you just need 2 more ordered pairs. And with this standard form, this is opening to the left, right? Because your a value is negative. Your a value is equal to negative 3, so it opens to the left. And there's a y squared. So let's start drawing a rough sketch here. Negative 7, 3. So we're in the second quadrant. And I'm going to draw something not to scale so that I could get the concepts done quickly. So negative 7, 3 is maybe here. Let's call that our vertex. Negative 7, 3. And I already know it's going to open to the left. So it might be wise to find the x-intercept. It looks like it's going to cross the x-axis. Now it's going to help us find three ordered pairs. So to find x-intercept is when y is 0. And now it just becomes a reaction problem. Why don't we react to this and figure out what this is? So negative 27 subtract 7. Negative 27 subtract 7 is negative 34. So when x is negative 34, we get 0. So it's way out here. And that is, let's see, let's draw an axis of symmetry. Let's use this as a mirror. And if we use this as a mirror, we should be able to see another symmetric point right over here. This is negative 34, comma what? Can you see it? 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 It's negative 34, comma 6. And now we simply play connect the dots, and you have graphed this parabola that's opening to the left. And there you go. Everything's labeled, so make sure your vertex is labeled if you want to. If you like to label things with a T-chart, that might be a little bit easier. So negative 7, 3 must be labeled in your T-chart. You have an intercept and then a symmetric point. So this is certainly a technique to graph a parabola. Let's circle everything. Not the scale. Says to graph these parabolas, but these are kind of strange. And you got to remember, one of the most important ordered pairs in a parabola is the vertex, because often or not, the vertex tells us if this parabola has a maximum or minimum value. In this case, why don't we take a look at these one at a time. Let's call this example A, and let's call this example B. This one here, if you complete the square, you would try to extract the vertex. So you have an x squared here minus 10x. Then we write a parenthesis here. I'm actually going to move the y's and the other constant over here. And that'll be a little bit easier to see. Now I could balance the equation. So remember, in completing the square, you divide this 10 by 2, you get 5. Square it. If you square it, you're going to add 50 to one side of the equation. That means you're going to have to add 50 to the other side of the equation. Now you just react to this problem. React to it. 2 times the quantity, x minus 5 squared. That's why we completed the square. It is now equal to what? Y minus 3. And this looks like the definition of a parabola. So we could find our vertex. Our vertex, well, it actually says the graph, so it doesn't have to say that we have to identify. So why don't we put our vertex in a T-chart? X, Y, we have 5, we have negative 3. And this parabola is opening up. It's actually opening in the up direction. So it's very likely that it has a y-intercept. So why don't we look for the y-intercept? If we look for the y-intercept, that means that's when x is 0. So let's say 2 times negative 5 squared is equal to y minus 3. What happened to my square? Let's fix that there. Ooh, let's try that again. Squared is equal to y minus 3. So 50 plus 3, 53. So when x is 0, we get 53. And I'm going to draw a rough sketch of this rather quickly. Where's the vertex? 5, negative 3. I'm going to draw a graph that's not to scale. I'm going to make sure of that. 5, negative 3. 1, 2, 3, 4, 5, negative 3. So let's say here. That's 5, negative 3. We have an x is 0, it's there. So this is 0, 53. This is, this ordered pair was 5, negative 3. We need another symmetric point over here. So we have an axis of symmetry. This axis of symmetry is a horizontal line. In fact, it's called y equals negative 3. That's how we label horizontal lines. You have to write an equation. That equation is called y equals negative 3. And we just need to label this third order pair here. Well, I know it is, well, stop it. What happened here? I'm going crazy. Why didn't any of you guys stop me? Let's try this again. I said this parabola is opening up or down. Why are you letting me opening it to the right? Let's try it this way. I'll draw a dot to scale this way. So 5, negative 3 is over here. This time over here. That's much better. And this is 5, negative 3. Now I have an axis of symmetry that's vertical. So we have to label a vertical line. How do we label this vertical line? X equals 5. So there's our axis of symmetry. X equals 5. I just need one more ordered pair. It's going to be over here. That ordered pair is going to be called, I'm sorry, not 10, 53. Simply by counting. And play connect the dots, and you get a parabola opening up, and this actually has a minimum value in the y direction. You can do a similar thing for part B. The key is completing the square. This time we're going to complete the square on the y values. I'll use this color instead. Y squared minus 4y, leave a space, is now equal to x minus 12. Minus 12. If you complete the square, you're going to add 8 to both sides. You're going to add 8 to both sides. There you go. Why do you complete the square? So you get a very, very nice perfect square trinomial. Y minus 2 quantity squared is equal to x minus 4. Once again, label your vertex. Label your vertex. Your vertex is what? H, comma, K. So it's 4 and then 2. And this one's opening to the right. This parabola is going to open to the right. 4, comma 2. So that means there's very likely going to be an x-intercept. So x-intercept is when y is 0. When y is 0. So 2 times negative 2 squared is equal to x minus 4. 12. X is equal to 12. So when y is 0, x is 12. Let's start graphing this now. Opening to the right, 4, 2. There are no y-intercepts. That's a good observation to have. I'm also once again going to draw this not to scale. So 4, comma 2, right about here, let's call the vertex there. Our x-intercept is x-intercept is 12, 0. And so we have an axis of symmetry. This time this axis of symmetry is labeled as a horizontal line, so y equals 2. And we need this symmetric point up here. What is it? What is it? What is it? Well, I know it's 12 units to the right. So how many units high? It's got to be 4. And then we play connect the dots. Boom. This parabola has a minimum value relative to the x direction. By the way, this is not a function. You know. How about the previous one? This one is. Yes, this one is a function. And there you go. You've graphed a parabola. But at least 3 ordered pairs. It'd be nice to put them in a t-chart, or you could label them on your graph. Make sure you draw your own graphs. Draw, 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 draw. That is the mathematical skill that you're trying to learn here. And then, of course, label, label, label. So you want to draw, 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 then label, 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 and label. We're going to go ahead and find the vertex, focus, directrix, and the axis of symmetry of the following parabola. The quantity x minus 4 squared is equal to negative 5 times the quantity y plus 5. First thing you're going to do is recall the definition. If you haven't already, memorize the definition of the hyperbola. The definition of the parabola. X minus h quantity squared is equal to 4 times p y plus 5. Y minus k, excuse me. I'm going crazy reading the problem. And in this case, we do have a negative here. So we have a negative 4 times p. So first thing you want to do is recall the definition. Remember, p is the distance between the vertex and the focus. Vertex, and the focus. Yes. P is the distance between the vertex and the focus. All right, we're in good shape here. That also tells us that P is the distance from the vertex to the directrix. I could give you a really, really generic sketch here. This parabola is going to open down, right? It's going to open down. Let me draw that a little bit better so that's not tilted. And there's a directrix. There is also a vertex. And then there's a directrix here. And the distance between this vertex and the directrix is called P. The distance between the vertex and the focus is called P. And that follows from the geometries of a parabola. This is why we call this the definition of a parabola, because the definition of the parabola is a very geometric definition. All right, let's find everything. We got the vertex already. The vertex is 4, negative 5. 4, negative 5 is the vertex. What are we going to find now? The focus. Focus is p units lower, than negative 5. So let's find p. In order to get the focus, we're going to need to find p. The focus and directrix involves finding the p value. So in our case, negative 4p is equal to negative 5, just by matching coefficients. P is always positive, so that's a big hint to you guys. P is 5/4. Notice that's always positive. So where is the focus? the focus must be what? A little bit lower than -5. So it's 4 comma -5 minus 5/4. And of course, you guys could use common denominator to get the ordered pair. So -20 subtract 5 is -25 over 4. And just use common denominator there. And so there's the focus. Well, how about the directrix? Well, the directrix is a horizontal line that's a little bit higher than -5. How much higher? Well, it's y is equal to -5 plus 5/4. Once again, find the common denominator. Remember, directrix is a horizontal line. Make sure you label it as a horizontal line. Sure, we have -20 over 4 plus 5, so -15/4. You must circle this equation of a horizontal line, or box. I boxed the equation of a horizontal line. Don't miss that. Let me go back and circle the focus. We have the vertex. Let me use some English here. People forget that in mathematics, you also have to use English. There we go. And we need the axis of symmetry. We found a directrix. Let me make this clearer. I want the vocabulary to be really, really clear. This is more about the mathematical English than the symbols. The symbols matter too, so everything matters here. Directrix is y There you go. That's clear. Okay. The directrix is an equation, and you have to write an equation. The axis of symmetry is an equation. You also have to write an equation. Axis of symmetry is x equals 4. What you're emphasizing here is this equation. The only way you can emphasize that is to use English. So don't just write symbols here. Try to write in complete sentences. So here's a period, here's a period, here's a capital V. Go ahead and try to do example B. You could pause it right now and give yourselves a shot. There you go. Everything's found. So make sure you label things very, very carefully. Notice I decided to write all my answers in complete sentences. Make things really, really clear. It's just not just mathematical symbols. The mathematical vocabulary must be stated as well. The equations of two conics are given below. You want to identify them by getting them in standard form. And of course, there are how many conics now? You have an ellipse, which has two standard forms. You have a hyperbola, which also has two standard forms. You have a circle that only has one standard form, and you have a parabola that has about 4 standard forms. So make sure you have memorized all the standard forms. You use them in practice already. You use them in homework. You've written them down in formulas. You've written them down on flashcards, whatever it takes to help you get familiar with them. You definitely want to practice computations, especially the mathematical trick called completing the square. Why don't we attempt to identify part A? So we have -5, and then we're going to complete the square on the values. When you complete the square, it actually indicates a transformation. That's another reason why you want to complete the square. It not only indicates the center or the vertex, but it will actually indicate a transformation. And then leave a space there. And now we're going to do the y's as well in part A. So we have -5. And then let's use a different color. Let's use y squared in blue. And then minus what? -4y. And then move the constant over to the right-hand side of the equation. So move the 5 over there. Now you complete the square. So the first term, we subtracted 5. So we're going to subtract 5 on the other side of the equation. The second trinomial there, we're going to subtract 20. So if we subtract 20 on one side of the equation, we got to subtract 20 on the other side of the equation. And now we react to this problem. -5 times the quantity x plus 1 squared minus 5 times the quantity y minus 2 squared is now equal to -20. So what do you think this is? Is it an ellipse or is it a circle? Let's find out. Divide the entire sides by -20. I said -20. And what do we get here? I'm being silly. Instead of -20, do you see a better number we could divide by? Let's try -5. This is why you want to have all your conics memorized. If you have them memorized, you can save yourselves a little bit time by doing a better procedure. You want to be efficient in mathematics, and the only way you could be efficient is by practicing a lot more than you think. This is an equation of a circle. Or why don't we just identify the conic to be a circle with a radius of 2. circle with a radius of 2 centered at -1, 2. There we go. So make sure you write it in a standard form and then give it its name. Give it its mathematical vocabulary. Let's look at part B. I'm going to erase the board now. So the first one was a circle. Part B. Same kind of tricks. We're going to complete the square again. -9, then put parentheses. What do we get? Y squared minus or plus 6y. So be careful of positive and negative signs. Those really matter when you're performing algebra steps. Let's complete the square. Let's add 16 here. So I'm going to add 16 over here. I'm going to subtract 81. Subtract 81 there, and then subtract 81 here. What do we have? We have 4 times the quantity, x minus 2 squared, minus 9 times the quantity, y plus 3 squared, is now equal to, what is that? Let's see. 45 minus 81. 45 minus 81. 45 minus 81. That's 36, right? But negative 36. This looks very interesting. Divide by negative 36 to both sides. And let's see what we get. We're going to get a y plus 3 quantity squared over 4 minus an x minus 2 quantity squared over 9 is equal to what? Is equal to 1. This is called a hyperbola, and it's actually opening in the vertical direction. So there's 2 parabolic branches opening in the vertical directions, so opening up and down. Make sure you're able to complete the square. The equations of 2 conics are given below. Identify them by getting them in standard form. So remember, there are 4 types of conics. 5 if you include the degenerate ones. But the 4 types of conics that you usually see are what? Are circles, ellipses, hyperbolas, and then a parabola. Make sure you know all the standard forms of each of these. The circle has 1 standard form, the ellipse has 2 standard forms, the hyperbola has 2 standard forms, and the parabola has 4 standard forms. Let's look at part A. In order for us to get them in standard form, you have to know this mathematical trick called completing the square. One of the best tricks ever. And we're going to leave a space here. And then minus y. I'm not going to do much with that. In fact, that tells me to move the y over here. I've done enough of these homework problems, to realize that my practice is paying off. I'm starting to recognize certain procedures under different scenarios. So why don't we complete the square? Let's add 12 to the left-hand side, and then we're going to add 12 to the right-hand side of the equation. Let's put this in one of the forms. 3 times the quantity x plus 2 squared is equal to y plus 1. This is almost in one of those forms. This needs to be x plus 2. Going to change that to be 1/3. And then y plus 1. And what form is this? What is this a form of? This is x minus h squared is equal to positive 4 times p times y minus k. So this is one of the 4 standard forms of a parabola. Is a parabola with a vertex. Let's label the most important ordered pair of a parabola. It is the vertex, -2, -1. We'll erase the board now and move on to part B. If you want to, go ahead and pause it, and you could attempt to do part B on your own. See what you get after doing one of the most famous tricks in mathematics, called completing the square. Ready to complete the square now. We are going to add 4. Add 4 to both sides. And then would add 64 to both sides. And now the equation is balanced. We react to this problem. Let's see here. Why don't we divide the entire sides by 64 right now? If I divide the entire sides by 64, and then use common denominator, I think we could get this into standard form rather quickly. So we have x minus 1 quantity squared over 16 plus y plus 4 quantity squared over 4 is equal to 1. And what is this a standard form for? This is an ellipse. With the major axis in the horizontal direction, right? This is an ellipse centered at 1, -4, with the major axis in the horizontal direction.